Today's lesson starts on page 5 of our Chapter 8's note packet, and we'll be covering page 5 and half of page 6. Now, when viewing this video, you want to have your graphing calculator with you alongside while you're taking notes. We'll be covering three things: common log, and then applying our log rules for product, quotient, and powers. And then we'll also be looking at a natural log. First, a common log. A common logarithm is a logarithm to the base 10. When the base is 10, the base need not be written as a subscript of the word log. We want to complete the following. Log of 1, what does that equal to? Well, since no base is written, the base is 10. So this would be log base 10 of 1 equals what? If we change this to exponential form, base 10 to exponent question mark equals 1. Well, 10 to what power is equal to 1? 10 to the 0 power is 1. What does log 10 equal? Again, when no base is written, the base is 10. So this is asking 10 to what power results in 10? 10 to the first is 10. So log 10 is 10. Or excuse me, log 10 is 1. What's log of 100? Well, it's asking us 10 to what power is 100? 10 squared, or 10 to the second, is 100. So log 100 is 2. What is log 1000? Again, when no base is written, the base is 10. So 10 to what power equals 1000? 10 to the third power is 1000. So log 1000 is 3. Okay. You do have a log key on your calculator, right? That is the common log key. So if I wanted a log of 1000, I could use the calculator, press log, and then type in 1000. And the result is 3. Now, an anti-logarithm is the power of 10 to an exponent. Specifically, x is the anti-logarithm and log x is equal to 3. X would equal 10 to the third or 1000. Find the anti-logarithm x for log x equals 0.3456. Again, if we want to switch this to exponential form, this would be base 10 to the exponent 0.3456 is equal to x. Now use the calculator. All right, use second log on the calculator, because if you look just above the log key in blue is 10 to the x, and that's what we're looking for. We're looking for 10 to the 0.3456. So I key in second log and then 0.3456. And we're rounding to 4 decimal places, so 2.2162. 2.2162. The next one, log x equals negative 0.2345. Again, the base is 10, so if you want, write this in exponential form. 10 to what power? 10 to the negative 0.2345 equals x. Go to the calculator, second log, negative 0.2345, 0.5828. Now what we want to do is, first let's recall our rules for log. Recall that the log of A times B, or the log of a product, expands to log A plus log B. Log of a quotient, A divided by B, is equal to, it expands to log A subtract log B. right? Division goes to subtraction. And log of a raised to the power x. The power comes out in front as a multiplier. This is equal to x times log a. And we're presented with the question here. 8 problems. It says if the log of 2 equals lowercase a, and the log of 3 equals lowercase b, and log 10 equals 1, this is common log 10, which does equal 1, write the given expression in terms of a and b. Okay, so we have the log of 6. So what we need to do is, we need to use the numbers 2, 3, and 10, either by multiplying and or dividing and or raising to a power, so that we can get 6. In other words, from the numbers 2, 3, and or 10, how can we come up with 6? Well, we can come up with 6 if we were to multiply 2 times 3. All right, so what I'll do is we'll write this log 6 as log of 2 times 3. Everyone agree that 2 times 3 is 6? Okay, so now we'll expand this. We'll use our log rules to expand this. Log of a product expands to multiplication, expands to addition. Log 2 plus log 3. Okay, well here's log 2. What does log 2 equal? It equals a. So replace log 2 with a. And log 3 is equal to b, so replace log 3 with b. And there we have. So we've taken the expression log 6 and we've written it in terms of a and b. Let's try number 2, log 4. All right, well using 2, 3, and or 10, how can we come up with 4? Well, 4 is equivalent to 2 times 2. So let's write this as log 2 times 2. And now use our log rules. Multiplication expands to addition. So this would be log 2 plus log 2. And now log 2 is equivalent to a. So this would be a plus a. These are like terms, so this combines to 2a. Okay, now again, keep in mind that we have log 2 is equal to lowercase a, log 3 is equal to lowercase b, and log 10 does equal 1. Now, so when we get to number 3 here, 20, log 20, first just think of 20. How can we represent 20? Using 2, 3, and or 10. Well, 2 times 10. Now expand. Log 2 plus log 10. Log 2 is a, and log 10 is 1. So a plus 1. Next, log 60. Take the 60. 60 we can write as 6 times 10, but we need the numbers 2, 3, and or 10, so let's break it down into 2 times 3 times 10. Now expand. Log 2 plus log 3 plus log 10. Log 2 is lowercase a, log 3 is lowercase b, and log 10 is 1. So a plus b plus 1. Number 5, we have the quotient. We have log 2 divided by 3. Okay, well it's already in terms of 2 and 3, so now just simply expand. Division expands to subtraction. So this would be written as log 2 subtract log 3. A minus b. Number 6, we have log of 6/10. All right, 6 we would write as 2 times 3, and 10 can stay. So we have log of 2 times 3 divided by 10. Division expanded to subtraction, and we have multiplication here that will expand to addition. So this would be log 2 plus log 3, subtract log 10. Log 2 is A, log 3 is B, and log 10 is 1. So A plus B minus 1. Number 7, we have log of 30 divided by 2. Okay, 30, we'll replace that with 3 times 10. Now expand, log 3 plus log 10, subtract log 2. Log 3 is B, log 10 is 1, and log 2 is A. So B plus 1 minus A. Number 8, log of 9 divided by 20. Okay, so 9 would be 3 times 3, 20, 2 times 10. Just be careful, we do have 2 terms in our denominator. So just so I have more room here. This would be log 3 plus log 3 minus parentheses log 2 plus log 10. Squeeze that in. Log 3, B plus B minus parentheses log 2 is A plus 1. So this is 2B minus A minus 1. Now going on to the next page, which is a natural log. Natural log, or ln of x. A natural logarithm is a logarithm to the base e. Recall that e is an irrational constant that is approximately equal to the decimal 2.718, 281828, and it continues. The expression log base e of x is written as ln x. You can always rewrite ln as log base e of x, and vice versa. If you have log base e of x, you can write it as ln. We have ln on our calculator. Right? It's right beneath the log key. Here you have ln. We want to solve for x to the 3 decimal places. X is equal to ln of 88. Okay, so we just go to our calculator, press the ln button, and then 88. And we're rounding to 3 decimal places, so 4.477. We're solving for x. Number 2, I have x plus 1 equals ln 200. We'll get x by itself, subtract 1 from both sides. X equals ln of 200. This is its own term. Subtract 1 is outside of that. And we go to the calculator. See if I can get them both in view. Here we go. Okay, so ln 200, close the parenthesis, subtract 1. 4.298. Number 3, get x by itself, add 1 to both sides. 2x equals ln 44 plus 1. and then divide both sides by 2. So we're keying this into the calculator, and I would key it in as a fraction. Right? Don't key it in one step at a time, but key it in as a fraction. So alpha y equals my numerator, ln 44, close parenthesis, plus 1, denominator 2, 2.392. Number 4, we'll get x by itself. Subtract 2. 3x equals ln 500 minus 2, and then divide by 3. And this is what we're keying into the calculator. All right. So if you have your calculator keyed in, otherwise I'm going to leave that blank for now, and we'll key it in class together. Now, we're still solving for x to 3 decimal places. All right, here we have e to the x equals 88. Well, first let's write this in log form, right? This is exponential form of an equation. Let's write it in log form. Base is e, exponent is x, answer is 88. So remember log base. So log base e of 88 equals x. Remember, log base e is the same as ln, all right? So, or we can write this ln of 88. Well, ln of 88 we have from above, so I'll just copy it from above. That's 4.477. Number 6, e to the x equals 200. Write this in log form. That's log base e of 200 equals x, or ln of 200 equals x. What's the natural log of 200? Go to the calculator, ln 200, 5.298. Okay, and number 7, e to the 2x equals 2,000. We need to solve this for x. Let's place this in log form first. So log base e of 2,000 equals 2x. We don't have x by itself yet, so we divide both sides by 2. And log base e is the same as ln, so we would key in ln of 2,000 divided by 2. .800. Okay, and we're going to stop there for today, and we'll pick up and do number 4 if you didn't have a calculator with you for these notes, and number 8 in class tomorrow. Thank you.